Hello, everyone. So today uh, we are going to be listening to the keynote of the Legacy of Skylab. And my name is Dr. Michael Zeilenhofer, and I'm a part-time faculty member with the Department of um, Space Studies at American Public University. And I'm just going to give an introduction to Dr. Arnold Nagassian, who has served as the National Aeronautics and Space Administration Associate Administrator for the Life and Microgravity Sciences, Designate Agency Health and Safety Official, Chief Medical Officer and Senior Advisor for Health Affairs. He managed and funded an extensive portfolio of research and development in the areas of space biology, medicine, physics, and chemistry. He was also responsible for the oversight of the NASA workforce, occupational, and astronauts' health programs. He is a fellow of the American College of Physicians, American College of Preventative Medicine, Aerospace Medical Association, the American Aeronautical Society, and a full member of the International Academy of Astronautics. He has received numerous awards and medals from the U.S. and foreign governments for contributions to education and humanitarian help using telemedicine. So I would like to just introduce Dr. Arnold Nagassian, and I'm looking forward to the keynote, The Legacy of Skylab.
Thank you, Michael. Can you hear me well?
Yes.
Thank you. Thank you for your kind introduction. I would like to thank PSO and the APUS leadership for inviting me for this lecture. And it's a pleasure always to be here and to interact with the audience and the students when they have any questions. So a lot of the things that I was going to talk about, a lot of the topics have been addressed, excuse me, have been addressed yesterday. But, there are certain vignettes that are not really as scattered throughout the literature or the obscure websites of government agencies. And I'm trying to pull together all that information and present it and tie as where we were in Skylab and how it affected the future. At this time, I would like to reveal that I joined NASA with the Apollo 17. That's how old I am now, and that was my first mission. And I was both an investigator and a flight surgeon for Skylab. So, it was a long 1 year on the consoles at Johnson Space Center in the mission control, looking at the first station, and then going from that immediately to become the crew surgeon for the first international mission, Apollo-Soyuz. So what is Skylab legacy? I think Skylab legacy is very rich. We are still discovering what it did. We are still publishing. So let me give you some disclaimers here. Most of the images are from NASA. Some of the images and text are property of Springer and the author, myself. And this presentation is, I see a typo, for educational purposes only, and I will correct the typo immediately since my spell check did not take it. Okay, it's for education purposes only, and the disclaimer is the opinion I expressed as solely mine from my experience, do not represent NASA, APUS, or George Mason University. Let me begin with, I was talking about two vignettes. One, it says that the history and the past is a window into the future. But I like the Churchill always. He always had such a good inspirational statement. It says that the farther backwards you can look, the farther forwards you are likely to see. And in many agencies, many a lot of people in the industry keep forgetting that experience that they had or what they learned and try to go and do new things or reinvent the wheel. Sometimes when you reinvent the wheel, it becomes a square. And most recently, NASA has really established a very, very useful program and a useful office at NASA headquarters, which collects the experience and the lessons learned to be an input to future NASA managers, engineers, and scientists. So that's a very good thing to do because lessons learned are important. So let's go to the learning objectives. One is this, I would like to talk shortly about the historical review of the first, not it's US, not world, just United States space station. To address briefly the Skylab operation engineering and scientific accomplishments and Skylab lessons learned and applications. Now, if at the end of my talk you did not get a sense at least partial to that, then I didn't do a good job. So what is the outline? We talk about learning objectives. I will talk about historical perspective, which is very interesting because a lot of the history of Skylab predated me, my arrival at NASA, or predated I, and and it was and everybody had an opinion how it all started and what happened. And it's very hard to dig into that and to find what was the right mix of information. Smith is the Skylab Medical Experiments Altitude Test. Yesterday, I was on a panel that Professor Albin chaired, which was the analog and simulations. And believe me, that NASA still has analogs and simulation for every mission that they are going to go and plan. So Smith was one of those missions which was conducted at the Johnson Space Center in an altitude chamber, and we'll talk later on about that. Then Skylab orbital configuration and why we went to that configuration, planned investigations, experiment. And what I like is that the Skylab 2 crew, because the first Skylab was the station was launched without the crew, uncrewed or unmanned, whatever pleases you. But the crew went in and they found a lot of problems, and they called themselves at the end of the mission, "We can fix anything," which is really a good statement, given that these days many people cannot fix many things, and it's always costs more. Then we talk about habitability, what we learn about living and working in space, and talk about biomedical and science results, the legacy and conclusions. So historical background, let's talk about that very moment. So Apollo, Mercury, Gemini, and Skylab were born out of the Cold War and the race to space, because space was a program that country used to demonstrate the technological savviness and achievement and how wonderful they are. But what happened to the Cold War space race? Well, Yuri Gagarin was launched first, so the first man in space was the Soviet, and the Soviets had many firsts, and they used that for a very good tool for propaganda and demonstrating the really technological achievement. NASA was falling behind in the approach, blowing up rockets. But then John F. Kennedy gave NASA a lot of money and said, hey, by the end of this decade, we are going to do a hard thing. We are going to land on the moon. And really, we landed on the moon, okay? But why didn't the Soviets do that? A couple of months before, they were going, Korolev, the Soviets brought the same type of German scientists over as we did, but we got Werner von Braun, who was very known. But the Soviets got also a lot of scientists, and they built the N-1 rocket. The N-1 rocket seen here at Baikonur exploded before the launch. They exploded because of the problem. The general was in charge. Rest in peace. This, the rocket did not launch at the command, and he sent all the engineers and everybody to defuel the rocket so they can repair it, and the whole thing exploded. So if you guys go to Baikonur, you can still see the buildings and the places which are littered with shrapnels, have holes in the walls. So suddenly the Russians were not going to the moon, so we went. Little known, uh, little known fact, or people don't realize that the Russians tried to recover by sending a moon lander before we landed on the moon, before we landed humans the moon. And it was a robotic lander. So what did the lander do? He just crashed. So unfortunate. Okay, so what was the first space station? The first space station was post N1 disaster, launched 19 April 1971, deorbited 11 October 1971 because of the fire which occurred inside the space station and was thought to be not that reliable. And first crew Soyuz 10 failed to dock on 22nd April to the space station, and the second crew docked. There are three of them, Dobrovolsky, Volkov, and Patsayev. And that's the configuration, Soyuz docking with the space station. That space station salute was also based on the basis of the Soviet military space station, Almaz. And there was a lot of similarity in the way the space stations were built early on by US and the Soviets. And yes, people were talking about China the previous session. I was listening about China policy. And Chinese picked up the Soviet design and just using that for their space station. So what the Chinese is doing, they're taking a little bit from here, a little bit from there. And when I visited China, Space Biomedical Institute of the Chinese People Republic of China, People Republics of China Center. Okay, I love that. Then you can see that they had, I was able to communicate with them. I don't know Chinese, but I was able to talk with them in Russian. They were all trained in Russia. They had a lot of Russian hardware given to them, and then they borrowed some more from other countries. And what happened to NASA? Why did NASA went to Skylab? They had four missions to the moon planned. Well, it's very simple. Apollo was successful. We done it. We were happy. We were celebrating. And then we got back to the basics. Well, unrest in the United States, war in Vietnam, civil rights movement, and all kinds of things happening, cultural changes, and big cultural changes at that time. And that's the peak of NASA funding. And then, whoop, the whole budget went down. And the only bump here is the rebuilding after the Challenger disaster. When the Challenger exploded, NASA was given some money to replace the Challenger and to get another space shuttle. At the peak, the workforce was 400,000 people throughout the United States. That's the 1960s. Okay, our population was about 200 million plus, and that's civil service and contractors. Since then, the number of contractors decreased, and NASA today, as Zubin said, is basically funding contractors to launch his spacecrafts and other things so they can focus on Artemis. So what were the Skylab's objectives? NASA always wanted a space station, okay? And they wanted the space shuttle. And they wanted the space shuttle and the space station work together. And what they wanted to know, because there was a lot of movement, a lot of enthusiasm going back to the moon and to Mars, they wanted to know what are the limits of human existence in space. And they wanted to expand our knowledge of sun on Earth. At that time, we didn't know too much about the sun. We knew that there was the largest solar event in 1858 or whatever, which affected the telegraphs and everything else. But people did not know, and they want to know about the effect that sun flares have on systems and satellites and things like that. So these were the primary goals. So what was the beginning of Skylab? Actually, very interesting, if you go back and look, and nobody will really talk about that, NASA wanted a space station. So NASA started to plan for a space station early on. And the space station was primarily driven by Werner von Braun, who came with a group of Germans, V1 or V2 rocket scientists, and we're at Marshall Space Flight Center. And Lyndon B. Johnson wanted a center also in Texas, so we got the center there. And there were two competing outstanding engineers. One is Werner von Braun, and the other one, Max Faget. Max Faget was probably one of the two people at NASA who knew the ins and outs, the details of the space shuttle that he designed. And this is Gilruth, who was the center director engineer, who was also one of the foremost space engineers. Jack Kinsler, I just put his image there because the Safe Skylab we talk about by building the parachute, designing how to save Skylab. Just to amuse you, we used to pick up astronaut in the water. And here is the Tycho, the old Tycho. That was my first aircraft carrier cruise in the South Pacific. No portholes, nothing exciting. But it is refueling. So you have a chance to look at that refueling at the two ships running side by side and, high waves, and you wonder what's going to happen. The reason I'm putting it because sometimes the monotony of all those things is broken by some really funny things which can happen. I don't have the picture of that. I couldn't find it, but there was a Russian trawler always following our rescue ships. And at some point in time, we asked them to move away because they were really in the zone of the crew landing and one of the missions. And so they told us that they're there to help. But anyway, just for laughs. So Skylab orbital workshops was sitting on top of that here. That's the upper stage, the third stage. And the rest of it here was, that's the telescope and docking adapter. But here we had the crew quarters and this part. So this is the part where the configuration, launch configuration. This is the Saturn V. It was one of the Saturns left from the Moon program, lunar program, and the question was what happened to the other two Saturns, and we'll talk a little bit later. So Skylab is launched, and we are planning 3 crew members, 3 crew teams. This is the first Skylab crewed, which is Skylab 2, because Skylab 1, if you recall, was launch empty. This is Skylab 2, and this is Skylab, I'm sorry, Skylab 3 and Skylab 4. I have the red marks under some of the names. These are the astronauts who passed away. Most of them passed at the old age, about 80s. Many of them were born the same year as I was born. Joe Kerwin was invited, but he couldn't come. He was on travel. He was the first physician in space. Pete Conrad died at a younger age, at the age of 60, I think a motorcycle in Florida. Who were the contributors? Well, the contractors were everybody was working there. Those are the big ones. But the agencies which helped us were the National Academy of Sciences. They reviewed, peer-reviewed the Skylab proposals. They also helped select, and the influence was to get career scientists on board. National Institute of Health did contribute to us and work with us. United States Air Force, United States Naval Research Laboratory, and Dr. Ashton Gabriel, who is passed away, and his son-in-law is now at Brandeis, having a rotating room, Brandeis University. He was the foremost expert in the world on vestibular dysfunction. So he was at that time at Pensacola, and he was brought in to do neurovestibular studies and American Institute of Pathology. Why are they important? Well, if you recall, the Skylab, the Salute 1 crew died on reentry. And we didn't know what happened. And we knew that anecdotally, they were not exercising enough because of the vibration that they created. The solar panels almost were in danger to break loose. So the ground control told them not to exercise that much vigorously. But we didn't really know why they died. At this time, before Skylab started to be launched, we had our relationship with Soviet Union start to warm up, and they told us indirectly, verbally, that they died because of the decompression sickness, since one of the malfunction of one of the valves. All right. So that helped us to have confidence that the crew did not die because of any other probably serious problem. So let's see. So what was the Smith exercise? So he's Bob Crapen, who became still alive. He is one of the great pilots, astronaut pilots at NASA. And there is Bobko, and there is Bill Thornton, a physician who flew later on the shuttle. He is Bill Thornton. He is very active, very innovative, and an inventor. And he is working, you won't believe it, on the bicycle ergometer. He broke the pedals. As a result of that, we were able to identify malfunctioning of the bicycle ergometer, which would have ruined the whole exercise program on the space station. Said spare parts with the Skylab 2. And after 56 days, they emerged, and here they are. And they were greeted with a lot of fanfare. And here is the chamber, which was an altitude chamber, test chamber. That's where they spent all their time. And they worked very hard to identify hardware failures. So Skylab Science, there's a service module, there is command, there is the Apollo telescope, lunar mount, those are solar panels. There is the orbital workshop and the instrument panel, Earth Sciences, and the workshop had all the biomedical. So what were the investigations? Biomedical was endurance, living and working in microgravity, study of the Earth crust, observe oceans and beneath surfaces, the sun, life cycle and electromagnetic activity, astronomical observations, comets and other phenomena, material sciences, manufacturing alloys, crystals, and fluid. And then out of 1900, we started to use student experiments. And it involved 28 scientists from 28 countries. So it was a sole U.S. spacecraft developed, and all the stuff was ours, instruments. There were international participation. Let's see what. Payloads, imaging cameras, white light coronagraph. You can go down and Earth-mounted resources and instruments, plus additional pictures that they took. And there were a lot of experiments done looking at the sun. And then in 1973, Comet Kohutek, which comes from maybe I don't remember, 90,000, 75,000 years to the solar system, probably from an outside body, just appeared as Jupiter. And he is the astronomer, famous astronomer Kohutek, who is in this in the mission control, talking to the crew and directing how they should take the pictures of the Kohutek. One of the major things, obviously, was that we didn't find any helium in the tail of the comet, but there are other findings that you can. It's beyond the scope of what I'm going to talk. Microgravity experiments, that's the station, and the furnace, welding, brazing, metal melting, and crystal growth and water fluid dynamic, which was very important when I was in charge of the life sciences and microgravity sciences. It became clear that fluid dynamics is very important for understanding the physiology and vice versa. Okay. So we can fix everything. Apollo application program, that's what the crew Skylab 2 called themselves after they put the parasol. You can see the last crew of Skylab 4, went and added another, Skylab 2, I'm sorry, the second crew, added another parasol because the one that the first Skylab crew put on board, which is in the background, did not cover the whole sun-exposed surface of the sky. Okay, so you can see here, Skylab went up, everything worked well. The gases of the third stage got into the second stage, and then micrometeorites got expanded and tore off the micrometeorites, which in turn tore off the weakened solar panel, one of the solar panel, and the fragments just jammed the other solar panel. So one solar panel not deployed, the other solar panel out, and exposed surface of the gold, whatever leaf, which is to protect against radiation, micrometeorites, is exposed. And who are the people? These are the unsung heroes who took the mylar and nylon and aluminum, and at Johnson Space Center, they created the first shield. And those are the seamstresses and engineers who are really working on creating the first parasol to cover this area. Picture from Skylab shows things dangling while the first Skylab crew went and flew around. Okay, then second parasol was developed for the second Skylab, was brought in and was put in place. And what is interesting is that, you know, it is what we are saying, but the EVAs, they tried to fix it standing inside the Apollo spacecraft. It didn't work, almost lost one of the astronauts floating away. They tried to free everything. So they had a serious problem. And we had a very tense time, 24/7 in the mission control, watching the whole thing and trying to work the problems in the facility, training facility and water immersion facility of the Johnson Space Center, and pass on procedures to Skylab crew because they had some instruments, cutting instruments and things like that, and they didn't have a parasol with an extension fall to deploy, but the procedures were not well worked out. So what was the habitability? The Skylab operation, once it was made habitable, the crew deployed the parasol to the airlock, and then and then they start to cool off, and they found that the orbital workshop is not the atmosphere is not toxic inside. They went with mask to activate everything. What do you call the multiple docking adapter where they was working, and they activated that first. And once the fans start to work and they pressurized and depressurized the orbital workshop several times, then it was safe to re-enter. And the temperature, which was about 120 degrees plus, dropped down to 50 or 60 degrees, which was tolerable. So Skylab operation was data downlink 12 to 24 hours after experiment. Real-time biomedical research meetings were held to support the team and plan the activities. And there was always two teams working. There were three teams in the mission control. Mission control was, we were meeting, it seems like every 3-4 times a day to see if it's okay to continue. Once we passed the limit that the Soviet cosmonaut went, which was 20 days, 24 days, and we start the first Skylab. Going beyond that, we had experiments going, cardiovascular, vestibular, and everything else. And once the motion sickness calmed down, every day we try to discuss, shall we continue one more day, shall we continue one day? So all this time was continued, and the input was made to the NASA management to continue. Daily private medical conferences, communication with family, daily or as time permits. Life on board, there were good surprises. Putting trash, which was at the bottom of the Skylab orbital workshop. You can see the trash goes in. There was a big receptacle. So, everybody celebrated Christmas on the holidays in space. And here's the makeshift Christmas tree out of the remaining parasol pole. This is the Skylab 2 crew left for Skylab 3, a mannequin to surprise them that there was somebody sitting there because there was kind of a month or so between the launches. So when the Skylab crew would come in, they will be surprised they thought somebody is left there. And doing, having haircuts, you need to do that. And there was a shower. That's the only shower we ever had in space. And they also, you can see the crew member is holding, that's the Skylab 2 crew, Skylab 3, holding, I always get confused, holding the vacuum cleaner to get the hair out. Okay. So now you know there is, when there is those electric shavers that we have, groomers, which has a vacuum cleaner, where that came from Skylab as a legacy. Okay, waste management was designed only for men, not for women. That's why women did not sleeping. And that's the compartment with the sometimes uncomfortable, the crew is restrained, and so they don't float away. And you can see the head cap, which is for sleep monitoring, was done there. So and the crew reported at night when they were sleeping, they would see light flashes, which seems to have been Cherenkov effect of HC particles. Okay, then nutrition, that was talked about yesterday, and that was the only one which was very important time for the crew to have meals together, and that still happens in Skylab, on the International Space Station, and food bars from future missions, which were originated, was high energy food bars, were sent with Skylab crew because, in confine of small spacecraft, crew is not active and they feel they didn't use that much energy, except walking on the moon. And people thought that they don't need that much food, so they dropped the amount of food to be taken. And obviously, it was a miscalculation, so they had to supplement it with high energy bars, sport bars, and then this is the experiment. And when you recognize that all those things which are here are automated, and they were sent to different, and there were telemetry data attached. So this is what we have now. They evolved into the intensive care units, automated blood pressure cuffs, and automated EKG readers, and many other applications in medicine. So let's see. Okay. So this is the way the wardroom was, and where the bunk were. This is lower body negative pressure device that the Russians still use. We start to use it in space. And that simulates, sucks the blood down to the legs with the vacuum cleaner attached and the waist shield. And this is taking if you recall, in Apollo moon missions, we used to get the crews into the helicopter and hoist them to the spacecraft, which was not, or hoist them to the helicopter and then land them on the aircraft carrier deck. But then we decided to lift the whole crew with the capsule in to make sure that they don't walk and they don't pass out. Radiation, you notice that this is Mount Transit. You guys those things will be recorded and you can study them. Months on an ISS average is 8 millisieverts. Skylab 4 was half of them. So as you go, you double, but it's not a linear progress. And this is the largest solar flare recorded from Skylab at that time. And these are the sunspots which affect that communication. So what are the select outcomes of the whole thing? Significant lesson, anthropometry. People in space get in a fetal position. And this is the new anthropometry for space. At the beginning, they were designing stations like they designed for Earth, and the knees are getting under and you cannot work. And you float away, like you can see here, you float away, but you need foot restraint to stay there. And the reason you need the foot restraints is because you need both arms to work. If you float away and your legs are behind you and you hold to the workbench or whatever, with one hand, you have only one hand. So that's a big problem. And these are the tools and the foot restraints, handling tools, torque. You can see that, that's a torque. We didn't talk about that. What about a drill? What about a screwdriver? You need to stabilize it, and you need to make sure that there is a counter torque so the crew member hand does not float away. Housekeeping and ergonomic workstations, worker cycle, reliance on mission support, protective rails over switches. The first Skylab crew which went to do the repairs, they were trying to do the repairs in a place outside of the space station, but there was no rails to hold with. That was mitigated when we designed the Skylab, the International Space Station. Skincare. There were, skin gets dry in that environment because the atmosphere was 60% oxygen, 69% oxygen, 30% nitrogen. Like Earth atmosphere, the reason we did that is because we didn't have to have lungs collapse just with oxygen over a long period of time. Floating objects. Some of the crew members got some stuff into their eye. Dr. Kerwin removed from Pete Conrad's eye, and he admitted that in the public forum, a foreign body. And, if you don't watch what we are going with the clutter and everything else, you can get injuries at the beginning. Because in the space, you don't have any feel where your body is. Your eyes is your only system to orient yourself. So your legs are there, you don't know where they are, you hit and you can get a wrong switch for sleep or whatever. So that's why you have protective rails over switches. So you don't inadvertently push the switch that you don't want. Okay. So here's Nixon and Kosygin, or whoever it is, signing an agreement in 1970 on collaboration. And people start to think about, well, what do we do? The best thing to do in space is to have a space collaboration, which is very visible, and it's always for humanitarian reason, not military, though all the crews are military most of the time on the Soviet side, China, or Russian side. And here's Skylab 1 crew. It happened that they landed in the Pacific Ocean, where they took them from Ticonderoga aircraft carrier by helicopter to the California west side White House, and they speak Conrad giving the thanks to the both guys, and they're talking already about the joint mission Apollo-Soyuz that I was a crew surgeon. All right, the multiple docking adapter is here from the space station because that was the docking adapter that North American Rockwell and MPO Energia produced for Apollo-Soyuz. Okay, what else? What else? Well, very interesting. Food system. There's a lot of food which was prepared at Johnson Space Center, which finds its way as a production within the commercial. But most importantly, I want you to pay attention to that. That's what Chuck was talking, Mr. Professor Thorne was talking yesterday about the Papaho Indian mobile van that he showed. Uh, okay, go away. And this is a NASA system, and that's a physician bag. It has telemetry attached, it has a KG attached, we had an ultrasound, and there were otoscopes and ophthalmoscopes and blood pressure cuff and oximeter and everything else. And that was transferred, to a central place. So, and where did it end up? One of those bags ended up on Mir Station. We were flying together. The other benefit was the publications. So the Skylab medical altitude test, you can find it in some libraries. There's Skylab biomedical results and living in working in space, history of Skylab, the NASA publication. If not, you can write to NASA and see if you can get those. We are still publishing about Skylab, 20,000 peer-reviewed presentation, NASA technical memorandum. Let's see. What evolved the recovery Apollo to Skylab 4? This is the Apollo 17 stable 2 sitting up. The crew brought on deck of the aircraft carrier. This is the Skylab lifted with the crew inside. This is the crew exiting. You notice that the first crew is walking. The third crew was extracted with this, whatever you call it, this platform, because they were afraid that the crew won't be able to walk. And wearing the anti-gravity suit, they were able to walk, and they did very well. And probably the 3 months in space did not affect that much the crew. And the reason it did not affect because Dr. Thornton built a treadmill that was flown to last Skylab mission since the other two crews were falling behind on exercise. So from lifting up somebody, thank God around here, to walking on a platform, to something which didn't happen again, that's a Skylab, because people were fainting on Skylab because the reentry were entirely different. They were putting blood into their legs, and we wanted to know, can you run away from the spacecraft in case of an emergency? And nobody could do it. So we tried to extricate the crew in what we call it, those airport transport vehicle. We call it affectionately people eaters. And that would dock with a shuttle and take the crew out. They have exercise capability. While on aircraft carrier in the back, we borrowed from the NASA, from the military, mobile laboratories, 6 of them, for each one for the experiments and nutrition and physical exam. And they were made of metal, and we outfitted them and put them in C5As and fly them to the Hawaii or San Diego, wherever the aircraft carrier was, and offloaded them there, and that's where the crew exams were. And things repeat themselves. Here's the platform, is different than that, but here's the platform, bringing the SpaceX and extricating crew after 6 months on the stretcher. So what happened to the 18 Skylab or whatever, or 19? One of them went to the Smithsonian. If you recall, the Skylab 2 or the 3, they had serious problems, and when they docked, they docked 2 of the 4 reaction control system on the capsule, just Apollo's capsule, failed to work. So they re-entered with two. Finally, they re-entered using two of those out of four into the Earth atmosphere successfully because the approach to do it was worked out. But one of the Saturn V was transformed, which is now at the Smithsonian, we transformed it to a rescue vehicle in case we have to go and get them. And we would have launched it, an Apollo capsule empty, and there will be 3 crew members here and 2 crew members under. The 2 crew members here will be pilot and commander, and would have brought the crew back. But it didn't happen. We didn't need it, and kind of reminiscent of whatever the design of SpaceX. I'm stretching my imagination. Um, we started in Skylab student experiments, and we continue still. And the student experiment now counts about 2 million plus K to 12 engagement since Skylab. And we had 39, like I said, we selected 9. And here is Kathy Jackson. She's a professor at the university now, demonstrated the sensory motor experiment to Walter Cronkite, who is dead. He was one of the biggest fan of the space flight. He was the big commentator, especially during Apollo 13 accident. And here's Kathy Jackson with this Arabella, picture of Arabella. There were 2 spiders, Arabella and Anna. And that was another drama because, you need to read about that. It's so long. They won't come out of the vials. They were fed a fly meal, and they were sitting on the water sponge so they can drink. They wouldn't come out first, then they came out and spun the web, and everybody got fascinated in the mission control about 2 living things, 2 spider nodes with 3 astronauts. So they want to return them, but they died. And they brought them in there in the Smithsonian now, Air and Space Museum, and we decided that and it was determined that they died from dehydration. The Apollo crew even wanted to put the live ones if they were alive, into the spacesuit to bring them back. Big drama. So here is the Skylab B legacy. There's a Skylab, remember I told you, which was supposed to become the rescue vehicle. But what did we use the rest of them? Well, when we were planning for International Space Station, NASA designed the Space Station Freedom using the Skylab model, but larger. And they were going to put an artificial gravity centrifuge on the bottom. Then all the international partners were invited, and they said, hey, we don't want to live in a skyscraper here. Each one has a floor. Why don't we have modules? So the whole thing fell apart, and the plans to include with that Skylab with 1976 US bicentennial fell through, and the remaining Apollo craft were used for logistics, was put in storage and later delivered to NASA. But one of the major blockers was the Skylab planning for Skylab return, burn and return early because of the solar activity, and I was part of that team to look at it. So it was not a controlled reentry, but we were hoping that the Skylab will be there for the next 6-7 years till the shuttle gets there. And we were going to dock the shuttle and resupply that Skylab, and that had been the orbital station. Well, it didn't happen. Skylab re-entered before shuttle was not ready. Solar activity was high. And we did the same thing, actually, with the Mir station. Right. So what are the lessons learned? That's what Dr. Polk talked about. Limited resources and resupply was until a viable self-sufficiency is developed. It requires continuous performance and training. Reduce human operator error is important. And it creates a new psychological environment that's where you're in space. And some of the students address that. And the APUS is doing some psychosocial studies in their with the IAA in the inflatable modules. But you need to make sure that technology for extreme environment it will enable, will protect, but it requires maintenance and creates health risk. We need to address this while we develop robotics and everything else. We need to make sure that we can handle those 3 and 4. So do people adapt to space? The only one which adapts, we know, is the vestibular system. Motion sickness goes away, and they're fine. Though some astronauts ask that, the orientation of the floor of the habitat be toward the Earth. I don't think it will work unless when you're on the way to Mars. Earth-based standards of medical practice and Earth-based standards of occupational environmental health standards will feed into what we do in space. A patient on Earth is a bad model for somebody who flies in space because we take a very healthy problem, people, and we make them sick in the microgravity environment. So like Axiom plans to do this for tourists, a space station with artificial gravity. Well, I have come to the end of my presentation. I talk more than I should have. But here is, thank you. This is the picture taken. Some of the people are dead now. That's a helicopter. That's a US New Orleans is a single screw LPH, which is a landing platform for a helicopter. And this is us, the team which always in the recovery during a medical experiment. That's the medical team. You can see we are from all over the place. This is Dr. Bouchard from Germany, the NIH teams. And this is me. I was younger then. And thank you. It brought good memories. And I wish I had more time to share all of it. Thank you.
Thank you. This was an excellent presentation. I just want to take the time, there was a couple questions. One of the questions was, what is the most important lesson or some of the most important lessons NASA learned from Skylab? And I think that you had covered some of that with your part of your conclusion slides. But if you wanted to elaborate on that, we have a few minutes.
Well, the important lesson was the first step to extend human presence in space and the ability to design systems which are compatible with living in space. And the major lessons that we learn is that some of the changes like bone and muscle, and Dr. Polk talked today, continue. Some of them are adaptive and some of them are pathological. The adaptive is that you don't need that many red cells. The adaptive, you lose some fluids. But when you land in a gravity field, that becomes an impediment. And, there's a guy in 1776, he was an Italian who wrote the first textbook in occupational health. And his lesson is always stuck in my mind. because yeah, there's all the occupations in the 18th century or 17th that people knew about, working in the mines, effect on whatever. And then he talks about sailors on long voyages. And let me paraphrase his statement, is that, while you can take care on Earth of some of the problems, on long voyages, any problem is fatal. So you are with limited resources. As long as you're close to Earth, you might be in about a couple of hours back if you have major injury. But if you are on the moon, it's 4 days, probably won't be that easy to come back to definitive facility. The gateway itself, which is sitting there, the logistics, the gateway station, will not be a good place to have. They can store things, but I'm not sure. We don't have a hospital. And so, anybody who gets sick seriously might be a serious problem and can be fatal. So that's why we select very healthy people. So that's one of the major lessons that you need to understand. And one of the things that the second lesson
Don't
that
mean
we know
I
now
don't mean
from,
to interrupt. We're running over, so
yeah, please go ahead.
appreciate the extra information, and thank you for answering the questions. And again, this is an incredible talk.
Thank you, everybody. We'll see you. We hope to see you in the closing remarks starting in a couple of minutes.